Well, the other two parameters, C and D, are parameters from the supply curve. So let's look at those. See, actually, this stuff is really quite simple. Partial P star, partial C. And what will that equal? Go back to this expression right here. It's not too messy for you to see. A plus C over B plus D. So this is one you can get pretty quickly. What is partial P star, partial C? We don't even have to use the quotient rule on this one. What is the coefficient, Diana, on C? Yeah, it's 1 over B plus D. Again, go back to this expression. P star is 1 over B plus D times A plus C. So this 1 over B plus D is just the coefficient on C. So that is the derivative. Alternatively, as we did before, you could have used the quotient rule, and you would get the same result. Okay. The derivative of the numerator with respect to C is 1. Multiply that times the denominator, minus the derivative of the denominator with respect to C, which is 0, times the numerator over B plus D squared. So you get the same answer we got before. Okay. And what is the sign of this partial derivative? It's always positive. So, Bernard, what does that mean in words?
As C goes up, C goes up.
Exactly. And what if C were to go down?
C goes down.
Exactly. C and P star move in the same direction. And actually that makes sense if you think about it, because C is actually minus C is the intercept. So as the C gets bigger, the supply curve actually shifts downward because the intercept is minus C. Let's show that. Let's illustrate here the case where the parameter C gets bigger. Here's our demand. Here's our supply. Here's our original equilibrium price. Now when C gets bigger, say this C value is originally 10, and then it goes to, the C value goes from 10 to 11. Then our intercept goes from minus 10 to minus 11. So it's actually moving down. So as C prime gets bigger, our supply curve actually shifts downward like this. And what happens to the equilibrium price? It goes up. So just as Bernard said, what's happening here is C and P star move in the same direction. As C gets bigger, minus C actually is lower. So the supply curve is shifting down. Okay. So in this case, what you have is basically a reduction in supply, and that leads to higher prices. Okay. Then the final one is this, partial P star, partial D. And again, the simplest way to get this is to use the quotient rule. The derivative of the numerator with respect to D is 0 times the denominator minus, what is the derivative of the denominator with respect to D? Ryan, what's the derivative of the denominator with respect to D? Not D, but this is, it's so simple it's almost hard. 1, because it's just the coefficient on D, which is 1. So like, what is the derivative? If y equals x, what's dy dx? Suppose y equals x. You take dy dx. What is it? 1. It's the same thing here. So the derivative of the denominator with respect to d is just 1. Okay. Times the numerator, a plus c, over the denominator squared. Okay. So this simplifies. You've got a 0 here, so this simplifies to just minus a plus c over b plus d squared. And, Ryan, what is the sign of this derivative? Negative, yeah. The negative sign out here, as well as the fact that all these parameters are positive, guarantees that this will be negative. So, in words, what does that mean, Ryan? Yes. P star moves in the opposite direction of D. As D goes up, P star goes down. And actually that makes sense because what is D geometrically in our supply and demand diagram? Where does D enter this supply and demand model? Anybody? Where does D enter in the supply and demand model? Yeah, it's just the slope of the supply curve. Our supply curve is just this. And the slope of the supply curve is just D. So as D gets bigger, then what happens to the supply curve? Yeah, it gets steeper. Okay. The slope is D. So as D gets bigger, what happens is the supply curve becomes steeper. It goes from S to S prime as D goes from D to D prime. A bigger slope means this is steeper. So it becomes steeper and the price goes down. Okay. As that supply curve becomes steeper, then more inelastic, the price is going to go down. Okay, moves in the opposite direction. Okay. Now, everybody understand that? It's simple comparative static analysis. How does one of your endogenous variables, the equilibrium value of that endogenous variable, change as one of the parameters or exogenous variables in your model changes? The simplest way to do this is to use a partial differentiation and then sign your partial derivatives.